Hey, okay, so I'm going to try and record something else. I'm actually going to record my webcam, see if I can actually talk to you about something while I'm... It doesn't look very good. Can you actually see what that says? Okay, so up here it says vertex, mesh, segment. Here it says segment, vertices, mesh, position with length, depth, and rotation. And at the bottom it says mesh vertices. It's kind of trippy. How's that looking? If I gotta get this to work. Okay. Like this. I don't know if I can rotate this thing. Okay, why am I drawing this out? Okay, the point is I don't know if this is going to work. Okay, let's just stick with this diagram. Okay, so vertices. The point is that I'm trying to trace I'm trying to figure out like who starts everything. What's the middle? You know, what's the middle? Where's the point at which everything comes out of? You know, should I base, you know, like, okay, so we got obviously we're gonna have classes for all these things, for vertice, for a mesh, for a segment, whatever objects we decide on. Like, we're gonna build up classes for them to kind of represent that thing, right? Like, now we have a path, and I've now also suggested we have a chain. Okay, so what's actually going on, right? It's like, well, I mean, okay, I'm sure you agree with this last one, right? Okay, there's definitely such a thing as that on the screen that's going to be called a mesh, right? There's a mesh, that's a mesh, and the mesh is made up of vertices, right? That's something we can definitely agree on. Okay, now this next part is what I think is the best description of what we're doing so far in order to draw this path out, is that what we actually have is a bunch of line segments, right? We've got a bunch of line segments. We don't, you know, the fact that they're made up of points is kind of incidental. Like, you know, we don't use the fact that there's points there except in order to calculate the position of the line. Like, that's the only thing that we're really trying to do. There's a section of line and we try to figure out the position based on the length. And then I've, you know, now saying depth and rotation, which is, okay, so if the depth is 0, right, then all the length is saying is that for the start of the line segment to the end of the line segment, you know, the depth is how far along you are, right? The length, I mean, the length is like how far along this line. Like, let's say there's a line going along like this. Like, the length is how far along, and there's your position right there. Now depth, if you're along the line, depth is saying, okay, perpendicular from that line. That's your depth. That's why when depth is 0, you're just touching the line. Do you see what I mean? And then rotation is like in 3D, like, you know, you're rotating around this point. I think it's called polar coordinates. But somehow I haven't really convinced myself of it yet, but it just feels like these coordinates are the most natural. But that's basically all we do when we're bending. That's all we do, is that we calculate this value, a position for each one of these guys, for each vertice. Now, why did I put the vertices underneath the segment? You know, what do I mean that a segment has vertices? Well, that's how we've described it so far. So you go to these line segments and they're all kind of connected, and then you got these meshes that kind of fall over them, and the one mesh doesn't actually fall on top of a certain segment, right? What actually happens is that some of the vertices of the mesh fall on one segment, and some of the vertices of the mesh fall on another segment, right? And if the mesh is small enough, you can have several meshes inside of one segment. So that's why the segment actually has a relationship to these vertices, and each vertice, a segment has certain vertices. All of the vertices on the screen that we're bending, every single one of them belong to a single segment, not two, not four, just one, right? Because it's on top of that segment. And every single vertex in that segment belongs to a certain mesh, right? So you see how, like, I'm just drawing out the relationship of what's going on. Like, that's why I've drawn out this one at the top. Like, we have vertice, and each vertice on the screen belongs to a mesh, and also belongs to a segment. So these are three different approaches that we can have to actually design this object, design our object structure. We could create a vertice class and have a mesh member variable and a segment member variable. We could create a segment class, and it has a list of vertices, and each one of those vertices somehow connected to a mesh. And it has a function called position that takes in length, depth, and rotation. And already we have a mesh that's made up of vertices. This is something we're stuck with. Right? Okay, so why am I doing this? Again, like, what is the... I just keep thinking, okay, where am I going to put the code that updates things? Like, where do you put the code that says, okay, I need to update these points because the segment has changed? That's one thing that could happen, right? The segment could change. Like, all of a sudden, you have the segment that's going like that. Now all of a sudden it's going... So all the vertices that connect to the segment have to move. Correct? Right? So all you do is you loop through the vertices, you get the mesh out, and then you say, get the position. Right? I even wrote the code for this. Right? For each vertice in vertices, right? Now we're sitting in a segment. Vertice.mesh, right? This is literally just a normal mesh object. .vertices, which is the mesh array. Open square brackets vertice.index, right? So inside of this vertice class, I'm storing out the index that's inside of this array. So we can just do direct array access. And then we say .position, right? Because that vertice, actually no, it's not .position. Okay, scrap that because it's a normal vertice. So you need a 3 vector. Equals get position, vertice.length, vertice.depth, vertice.rotation, right? So that's where this get position is. It's just, I'm just gonna, okay, so I'm gonna scrap this. Okay, let me just now, equals, what was the function called? Equals vertice.position, there we go. There we go. Equals vertice.position, right? So vertice.position, and I pass in all the thingies, right? I mean, okay, clearly I don't actually need these here. I could just put them as member variables into this function. If I'm calling from this function, then I could just say position, right? Oh, that's a good point. I could just say equals position, and then I just pass in. I have to pass in vertice.length. I have to say vertice.position, but maybe I'm in the vertice. No, I'm in a list of vertices. What the fuck? Where do I get the list of vertices? Oh, because I'm in the segment. Right, okay, and segment has get position. So it'll just be position. Okay, that makes sense. So I'm sitting inside of a segment right now. All this code is sitting inside the segment. And I'm saying, okay, the segment has a list of vertices. Loop through them. Get the mesh out of it, and from that get the array of vector 3s which define the vertices, and then for each of this vertice get the index that it points to in this mesh, and then set that to the function position, which is inside of the you know, it's inside of the what am I talking about? It's inside of the where are we now? We're inside the segment. No, inside the segment class, and it has a function position, which you just pass length, depth, and rotation. Will tell you what the position is of the point on that segment. Right? And these positions are like the original positions of the vertice on the mesh, typically. You know, but these positions can change. Like if the mesh moves back and forth, what happens is that this vertice.length changes. Because this vertice.length is actually the definition of how deep down along the segment the vertice is, remember. And then the depth is how far away it goes up. So the only time the depth would change is if you actually scaled the mesh up and all the vertices start to move away from the central axis. Right? And then rotation would change if you actually rotated either the mesh itself, yeah, it would be if you rotated the mesh, right? This is moving the mesh along, this is expanding the mesh, and this is rotating the mesh, right? So all the different relationships that a vertice fixed on a mesh could have to, you know, some line segments in space, right? Okay, so that's doing it this way, right? So that's saying this, right? Segment has a list of vertices, each one has a mesh in it. And then we also have this function position with length, depth, and rotation, right? So that's how I've done there. Okay, now, okay, what about this? Okay, each vertice has a mesh and a segment. Why did I do it that way around? It's like, well, okay, look, what can happen? It's like, well, one of the things that can happen is that the segment can change, right? How can the segment change? Well, at the moment we define the segment based on the 2 points at either end, right? The variables sitting at those points. So we can just say, okay, whenever the point changes, tell the segment that it must, you know, do this again. You know, do that every time one of the points changes in any way, right? And they'll just update all the positions of the vertices that are connected to the segment, right? Okay, but the big problem is, okay, now, but what happens if the mesh moves, right? So the line segment doesn't change, the mesh starts to shift either up or down, right? Well, fuck, if the mesh moves, then not only are all the vertices going to, this length value is going to change for them, but at the same time, the vertice could suddenly drop out of the fucking segment and then suddenly belong to another segment, right? So, you know, so, I mean, what the fuck? And where do we put that code? You know, so it actually has to go here and alter this fucking list, you know? Firstly, it's going to be very hairy. You have to go in there and constantly check, like, where's this value at? Like, this length value. You know, we could say that if this length gets to negative or above 1, then it means that it's dropped out. You know, it has to go to the next guy. Right? Now, where do I put that code? Well, on the editor, you actually click on a mesh and move it. Right? Well, you change the mesh. You know, change the mesh somehow. Like, you know, you delete it or you create a new one, you know. These are all the things that can happen to a mesh. So the mesh now has to respond to those kind of things. And so the mesh has to actually know what segments it's in. The mesh has to go and talk to this fucking segment and change these things here. Right? Which makes me wonder, I mean, why put it that way around? Why put the vertices inside of the segment? Why not just put the segments inside of the mesh, right? So a mesh can belong to 1 or 2 segments, or 3 or 4, depending on how big they are. Fuck. You see what I mean? So it's. I don't understand if there's like some kind of logical way, the best way to do it. Like the only thing I can think to do is to just write out every possible way that we could structure it, and then only then we'll be able to decide You know, on like, you know, I'm thinking, can you do both? Can you have like, you know, a mesh and then a mesh, and then when the mesh moves, you want the mesh to say, well, go to each of the segments that that my points belong to, or no, what the mesh would have to do is have to loop through all its vertices. Every time the mesh changes, it would have to loop through all its vertices and tell the vertice, you know, tell your segment that you've moved. Not even that, like, fuck. I mean, first you gotta check to see if it's out of this fucking segment. And if so, oh man, if so, if you're out of the segment, then you gotta switch over to a new segment, right? And then tell the old segment to delete you, right? So you got this like vertice to segment mapper, right? How do you map the vertice to the segment? And the reason I do this here, like this, is have a list of these vertices like this, is that it's just fast, you know? You don't want to recalculate all the vertices all the time. You know, if the segment changes, right? If this path changes, like, the vertices don't actually change. That's what's so funny about it. The only time the vertices will change is if the mesh itself changes. Either the mesh vertices change position, or the mesh moves, you know, or the mesh grows or shrinks or rotates. But if the mesh stays the same, then the moment the segment changes in any way, right, the vertices will be the same. And the only thing you're going to recalculate is the positions for each of them. Right, so this is like the most, the most optimal way to do it, like storing out all the vertices, like, and then only changing them later. But I'm just thinking, maybe I'm just not thinking about this clearly. Like, maybe there's a simpler way to do it that's optimal, you know? So you don't have to constantly recalculate everything. You only update things when they need to be updated, and this is why this has come about. It's like, well, we keep changing the path. So when you change the path, you know, the vertices have to be repositioned, but the actual relationship between these two doesn't change. The only time the relationship changes is when the mesh fucking changes. The bastard. This fucking mesh. See what I mean? So maybe if we start with the mesh, we have some kind of like new mesh object, like another one, like we'll call it a slab or something, and then that guy has a mesh, and that mesh has vertices, but then each vertice can actually, the mesh itself, this object can actually move, or it can change. And then what happens? Well, I don't know what happens then. Well, okay, so the vertices move, right? And only if the length changes, that's another thing. Only if the length variable changes, like only if the mesh moves along the axis of the segment, do you have to worry about whether or not to update the ownership, so for every single one, you've got to now say, every single one that's moved along that axis, you have to now say, well, maybe you're in a new segment, just check. And if you are in a new segment, well, then you got to do a segment switch. Fuck, it's pretty complicated, but again, like, I think that's got to be the most efficient way. Like, I can't imagine it not being. Fuck. Hello. Oh man, I don't know how loud this is. Yeah. Yeah, that's it. I mean, that unfortunately, that's how we've set this up. Yeah. You know, one way to do it without actually having segments, well, we could just have a global line. Anytime any vertex moves. I mean, again, like we could just say fuck the segments. Anytime a vertex moves, for every single vertex you just calculate the position, right? And you don't have to constantly switch arrays. Oh man, this is really killing me. Fucking hell. Anyway, dude, I'm gonna keep spazzing out about this. If you figure anything out, let me know.